Is it on? Yeah, okay. Thank you.
So it's a huge pleasure for me to introduce our invited speaker today, Aditi Lahiri, who's a professor of linguistics at the University of Oxford. She wrote 2 dissertations, apparently, one at the University of Calcutta and then another one for good luck at Brown University, and has continued switching hats, so to speak, ever since. She's made foundational contributions to the fields of phonetics, phonology, historical linguistics, psycholinguistics, and neurolinguistics. And she's continually worked to discover how the space of possible contrasts is both affected by language users' experience and affects that experience in turn. This theme of comparing the actual with the potential has been true of her work, whether focusing on one language as it's processed in a moment, one language as it changes over time, or in all languages that humans use. In addition to her own work, Aditi has been a dedicated and beloved mentor to scores of students, both those who are officially hers and those who are simply inspired by her and her research, and it's a personal pleasure to introduce her as I'm a member of the latter group. So, Aditi, over to you. Phonological constraints in language processing.
Thank you very much. You took 4 minutes. Can I still have some extra bit, please? It's really a great pleasure to be here and among so many friends, and particularly in an audience. And I'm just a phonologist, so I'm feeling particularly nervous over here. But it's very kind of you, and I'm very sorry with this horrid leg that I had to sit down, etc. Anyway. So we've listened to so many talks already about speakers and listeners, and this is a familiar picture in the sense that the speech output, the speaker is in control, the listener has to listen. And that's the problem, isn't it? I mean, the listener has no control over what the speaker is going to say. You are forced to deduce, understand, comprehend, etc. But adult speech is produced with great speed and accuracy. Words are selected from a mental lexicon of tens of thousands. I'm talking about more or less a Germanic lexicon, not a Turkic lexicon, let's say. And an average speed is about 3 words per second. This comes from Pim Lewald. For the listener, there are many problems: environments, vocal tract sizes, and of course, sounds of words are not discrete because they run into each other. So no word is ever spoken in the same way, even by the same speaker. Even if you try to say your own name 3 times in a row and try very hard to do it exactly the same way, there will be differences. So here is a sentence I've played before. This is entirely not true this year, but...
It always rains in Oxford, not in Cambridge.
Now, this little bit, those of who are familiar with waveforms will be able to say, you know, this is strident, this is a stop, this is a sonorant, but that's as much as you can really say. So that bit is Oxford.
Oxford.
Yeah, and if you cut out a word, again, it's a very familiar phenomena, it sounds shorter. This is another version.
Oxford.
Now, this sounds as if the pitch is going up, more like a question. And the context.
You need black shoes, wool socks, fur dresses, and a brown hat.
It had no Oxford in it whatsoever. You can try this out yourself. It wasn't manipulated, and indeed, for English particularly, given the lack of inflection, it's very easy to get this effect. If you had something like other Germanic languages, it's a little more difficult with the inflection. Now, what does the listener have to do? The listener has to receive the signal and extract relevant units, match it to the lexicon, but speech is variable, so what is the relevant information that should be represented? All variants with detailed specification, some abstraction. If you're a phonologist, you would assume automatically there is abstraction, but if there is abstraction, how much? The hypothesis I will entertain is that the phonological representation is abstract, but also not fully specified. We come to that in a minute. But in general, not just for feature representation, but the abstract phonological system of the native speaker and listener resolves variation and governs word recognition. Let's see to what extent I can hold this. But before we go into the details of this, a quick word, and forgive me if this is really boring, but to remind you that we're talking about sounds, not letters. And the phonological structure of a word is not just features, phonemes, quantity, but also feet, which we will come to in a minute. Certain colleagues have been making fun of my feet, but let's see where we go with this. Orthographic letters and phonemes. Now we are talking English over here. English is one of the worst. It's no lack of correspondence. One letter, many phonemes. So k, s, sock, and nose. You know, it's written with an S, but of course not pronounced with an S. G, and apparently nowadays children are taught a soft G and a hard G. The th, of course, Old English had a nice little thorn, but modern English has a th. And similarly, backwards, if you have something like badge or measure, cell or cell, you can do the other way around. But it's not just English. My own language, Bengali, has the same effect. So if you have the first word like camera, that vowel can be written one way, but it's pronounced in two ways. It can be a or an a. Similarly, a different letter, same vowel, it can be two different letters, but pronounced. The problem is, even like Korean, you try very hard to get a one-to-one correspondence. 100 years later, language changes. Of course, the writing system doesn't change. And there you go. Okay. So let's contrast sir and z. So this is a very typical thing that non-native speakers like me have a problem with. So orthography, phonology, sir, z, bus and buzz. If you're a Germanic speaker, like German or Dutch, and to some extent even Norwegian, you cannot hear the final voicing. Yeah, you can't hear the difference between a bus and a buzz. Now, in plural formation, English makes use of this. So if you have you can notice that some you write with a s, pronounce with a s, or you pronounce with a z. And then you go on to more plurals. If you have vowels or sonorants, l, m, n, you have a z. So basically, pata, ka with a s, and everything else with a z. There are more complications. I just skipped that bit. So basically, what you do is you take the plural suffix, it's written with the s, but they're pronounced with the features of the final sound. Now, what are features? The feature tree that, this is not the tree that every phonologist would agree with, but roughly the features are roughly the same. There are about 19 features, and this should cover all languages of the world, a combination of these. And the only ones we are going to refer to now are voice and strident. They're monovalent feature, they're present or absent, that's it. The features have acoustic as well as articulatory correlates. At the moment, they are named more or less articulatorily, but that's more tradition than anything else. So let's take a look at this. Basically, what you're finding that the plural marker, which is s or z, is governed by the feature of the preceding noun. And if the plural suffix essentially has the property of being strident, but the voicing of this comes from the preceding noun. So if the noun ends with pertica, you get s, match and voicelessness, and otherwise match and voicing. The third person singular does this, many things do the same. This is a typical English kind of a phonological process. Now, words vary everywhere else. You also get place of articulation. So, tada na become perba ma in the context of labial or kurga nga. So, if you have something like rainbow, it's usually non-native speakers would say rainbow carefully. Somebody like Garrett will surely say rainbow. And similarly with raincoat, it becomes raincoat. Okay. But it's asymmetric. And this is more or less true for all languages. The chances are that a coronal or a n, t, d will change, but not the other way around. Amtrak won't become Amtrak. Now, perception of assimilation can lead to change. So I'm going to give you an example from Chaucer. Now, this prefix in, which takes this, like, for example, immoral, impossible, etc., or innumerable, incongruent, immoral, impossible are now written with an M, innumerable, of course, with an N, incongruent, there is no velar nasal in English, so you write it with an N, but pronounce with an O. This is completely regular, but the prefix is Latinate, not Germanic. Romance loans came in the Middle English period, in Chaucer, which is about 14th century. And look at this. This is the manuscript. This is not a poem. Melody was not a poem, although it was a text. This comes from Manchester Library. And if I highlight this carefully, you will see that this is with an M. Yeah, and as we write it now, it's clearly an M. But you take the same manuscript from a different library in Wales, that means a different scribe was writing this, copying this, and here you see with an N. And similarly, over here, you again see an N. So the prefix was actually an N, but the assimilation must have been heard by scribes, heard the M, and the orthography changed accordingly. Yeah. So this assimilation is now reflected in writing. Now the question now is, how do native speakers cope with the variation? Yeah? So one possible strategy is keep the contrast sensitivity asymmetric. So a prerequisite is that not all features are represented. Yeah? So I'm going to argue that considering the noise in the system, asymmetries help actually to detect a contrast because the chances are not 50-50. And this is where underspecification comes in. So if you take these features again, the two that I have always assumed for various reasons, plosive and coronal, are always underspecified in all languages, but other features will depend on language-specific contrasts. Not all features are even present in all languages. The ones I will touch on are place of articulation in coronal, non-coronal asymmetry, height asymmetry, place of articulation and height in Mandarin, quantity in Bengali, and metrical structure asymmetry in German speakers hearing English. Now, what does it mean to say it's underspecified? Well, recall that this is the assimilation goes in this way, and the hypothesis is that coronal is unspecified in all positions of a word, not just where the assimilation takes place. So if you have green, sonnet, or number, with word final, word medial, or word initial, it's unspecified, while corresponding words with m, cream, image, or measure, they're always specified. So that basically, this is what it means. The representation is unspecified doesn't mean that the n is not produced with the coronality. So there has to be now a matching process from the signal to the representation. So how does the recognition process work? Well, the way it works is that the understanding is the perceptual system analyzes the signal for rough acoustic features, translated into phonological features, which are then mapped directly onto the lexical representation. But there's a three-way matching process. It either matches, well, that's great. It says mismatch, no, I don't like you. And the no mismatch is the most important one. That is to say, I tolerate you. I might realize that you are what I want a little later on, but you're not thrown away. This is sort of what happens on the telephone if you're trying to spell your name, particularly a name like mine. And then features from the signal which conflict are the mismatch. That's the strong one. Okay, I don't like you, out you go, yeah. So along, of course, with the phonological information, you get morphological, syntactic, and semantic information. So let's again remind ourselves, suppose you have the word green or sonnet, and you've heard green or summit, the unspecified, therefore there is a no mismatch, it is accepted. Yeah, it doesn't mean it's perfect, but it is accepted. The other way around, if you make non-words out of cream or image, making it in coronal, it's not accepted, and you should see an asymmetry. Okay. And how would that look like? Now, there are other words of word recognition. It's not that only I have looked at variation, Gareth being one of them, and the variants that have then, some people have assumed that everything is stored, which is more like the exemplar models that you would, and it's the easy way to go, because you can say everything that's varied will be stored. The feature parsing model says it's actually acoustically based. No, it is never a complete assimilation, so you get the information there. Gareth and colleagues have argued that it is actually in the position of the assimilation that you get backtracking and to be understood, but not everywhere. It's context dependent. And of course, Full takes it one step ahead and says No, it's everywhere. It should be. If it is underspecified, it's everywhere. So the predictions of this is basically if you have a word final position where you may be assimilated, then or everybody says it'll be accepted. If it's in the medial position, only full says yes. And initial, of course, initial position is sacred. For when it is a Martuna, then everybody says, okay, out you go. You're not accepted. So the one early one I had done was with using a sort of a semantic priming task, not ignoring the phonetics of it. So if you had something like sonnet and the visual target was poem, then of course you would be very fast because it is semantically related. So you do a semantic task ahead of time, of course. Unrelated computer, you get another reaction time. Then the question is, what about a word like sonnet? Would that activate poem or would that not activate poem? So what is it in terms of the reaction time? If it does, then you should assume that sonnet and sonnet would not differ. Or if it does, not significantly differ. The first experiments were all done in German, but of course no one really believes it unless you do it in English. So I'll just show you the English results. This was so the prediction again, sonnet would activate poem, image to picture, image would not activate it. In reaction time, that's essentially what we got. And they were not different, image, but image was basically almost inhibition. Okay. Translating this into ERP, I was interested in looking at N400 because after all, if there is no lexical integration, you should be getting a high N400. So you would see that, and you measure the N400, if you remember, is a component of the ERP. I mean, this audience knows that, of course. So if the amplitude is reduced when the target word is preceded by a word that is related, semantically or morphologically, orthographically. And that's what you would, if P said to drink, you would get a high N400. So for our purposes, same task, same essentially, and we were assuming the high N400 would be an anomaly. And the first one is the sonnet difference. This is a differential waveform. And over it comes the non-coronal one, the image. And it was significantly different. You get post-processing, of course, thinking, oh, why am I getting it now? But the initial reaction is that there is definitely a significant difference. Okay, this was also done with mismatch negativity, not my favorite task, but sometimes it's easier. So a lot of experiments were done on German. Again, I'll show you this now only in English. So to remind you about MMN, you have a standard stimuli. When we were young, we had a version of this which was for children with the sucking technique. The poor little babies were given a sucker, and you had closure duration per ber, ter, der kind of differences with VOT, and you had to suck. And either the babies, I had to look after some of them in my graduate days, and either they cried or they were upset. I was upset. I mean, the whole thing was a disaster. This is sort of like that, but I tend to stay far away from it, but my postdocs love it. Okay, so there's a deviant stimuli, surface stimuli, you get a higher MMN. If it's sort of an oops effect, like Natanen's, coming from Natanen, it was a very nice design. Okay, so we were looking at vowels. Remember, the vowels and consonants share features in my world. So here, we are not looking at, there's coronal dorsal, but there is also height. So we're taking sit, sat. Now, these are ablaut verbs, the oldest verbs in the Germanic languages, actually Indo-European languages. And then there's get, got. So the first set is, actually, they are very systematic. We don't think of them that way, but they are systematic. There is usually a height difference, I, or there is a place difference, o. Yeah. So they are real words, and then we match them with pseudo words and we cross-splice, etc., etc. In terms of us, the important thing is what is the mismatch relationship. So the mismatch relationship would be this. If they are high or low, you're going to mismatch in both directions. It's going to be symmetric. Yeah. So you expect symmetry in both. And the question over here was also, would words and non-words behave the same way? Well, insofar as vowels are concerned or consonants are concerned, there's a representation of those should behave the same way. So, and for o and e, there should be asymmetry because one is coronal, one is dorsal. So from o to e, no problem. From e to o, you should be a mismatch, at least initially. And if non-words behave the same way, pseudo-words behave the same way, that's what you ought to get. Now, this is what we got. So first looking at the high-low asymmetry, and you get both for words and non-words symmetry, essentially, because there's no asymmetry in this. If you look at coronal dorsal, where you would expect asymmetry, that's essentially what you get, and you get significant differences both for words and non-words. So English vowels exhibit the predicted symmetry and asymmetry for variety. And so this is the same with morphologically related words as well as pseudo-words. Now, this is more tricky because if you're assuming under specification, you also assume that in a context, if something is specified, it will spread because that's what assimilation does. It's pretty normal. So Mandarin sibilants, both coronal, and then you have two vowels, which are high and low again. The surface, the retroflex, is unmarked for phonological reasons. The vowels are marked for high and low. Both happen to be dorsal. Now, you would expect the height of the vowel to spread to the retroflex, which is, you don't need both specifications, you only need one to contrast it, right? And for the R vowel, you should get the low. So you would expect the surface vowel of sh to get one or the other. That means you would be able to extract that, yeah. Oops, don't fall. So if that is so, then you should expect an asymmetry. While for sir, it is specified, you're not going to expect anything to spread because it is fully specified anyway. Okay. So the predictions would be as follows. You would have low to low spreading over here, and you would expect symmetric MMNs and LDNs, late discriminatory negativity. And if you spread high to high, then you would expect something different. You would get no mismatch in one direction and mismatch in the other. So for sa, sha, we expect symmetry. For su, shu, not. This was quite recent, and it was just before the pandemic, so it was a nightmare. We did tone 1 because I wanted a flat tone for this. We've used it with other tones as well. And this is the oscillograms that you can see. So remind you, the standard deviant, sa, sha, su, shu. A total 4 blocks presented to each participant. So this is the summary of the plot. Now let's break this down. The strident fricatives show an asymmetry dependent on context. So in the context of low, the strident consonants do not mismatch. Okay. And you see no significant difference, LDN, no significant difference. However, immediately with the U, you see a very big difference, both for MMN as well for LDN. Now, you get asymmetry also in quantity. Now, English has long vowels and short vowels, although they are also with tenseness. They go with tenseness and laxness. They go hand in hand, but this was not true before. And there are no long consonants. But Old English had both. You had short and long vowels, and nowadays you get, and the lengthening of the open syllables made them long. Later on, so modern English, there is no difference. You get metan to meet, this lengthened, and etan to eat. And then the geminates became short, so setan, which was to set, is now a single consonant. So although Old English had them, Middle English got rid of them, but other languages do. So for example, Italian has them, long consonants, but Italian long consonants are subject to they go hand in hand with the vowels. Bengali has long consonants, many languages do. So this time you're looking at Bengali, okay. Now, the duration of a consonant, the physical difference is in a voiceless stop is simply silence, the closure duration, you see for pata pata. For the sonorant, you get, of course, the voicing, essentially, the sonorant voicing, and that's the length. It's almost double, yeah? So the closure to duration closure are really 100 to 200 milliseconds, and for singletons, 50 to 120. It's a huge difference. If you cross-splice the closure duration, you immediately get, and this is not Bengali, you get it in Berber, you get it in many languages, okay?
Kana, kanna, pata, patta.
Yeah, so you get you can clearly hear the difference. Now, if this is true, that the duration quantity contrast is represented by a mora, and would we see the same asymmetry? Is something shortened worse than something lengthened? Now, lengthening is a process which happens in context. That's really an assimilation usually. But shortening usually happens in a syllabic context. So one hypothesis is that you would get a mismatch. Mispronounced lengthened singletons do not, they would be all right, but not if you shortened. Okay. So here again, a semantic priming experiment. Let's take a single word like dana, which is wing, with the target bird, and kenna, which is disgust, with pocha, and then you make the shortened version for kenna and lengthened version for dana. These were run in Gokhale College, University of Calcutta. Okay. Here you see the semantic priming results. These are just priming, the same amount of facilitation for both singleton and geminate primes. But long to short, it only goes one direction. When you look at the ERPs, you again see the same. So if it is short to long, dana to danna, there is no significant difference, while shunno to shuno, it sounds really bad. And I think there are Bengali speakers in the audience who probably would agree. Okay, lastly, I'm going to talk briefly about the notion of pertinacity, which governing that a rule and pattern. Languages are slow to change. We think it changes. We think children, you look at these after COVID, you look at these language blogs and keep thinking everything has changed, the children have changed everything, etc. No, they haven't. They just, they have the same grammar. They've made up new words, yes, but they follow the language structure of what they already had. So it takes a long time for things to change. And words, when we borrow them, also, they take a long time to change, but they are borrowed according to the system. That's the claim of the native system, right? Now take this gentleman over here, who is well known, and in German, you would pronounce it as Van Gogh. In English, as I understand, in American English is Van Gogh. In British English, my pronunciation would be something like Van Gogh. And the Dutch original, I hope there are Dutch speakers here, is Van Gogh, both a ch and a Gogh, right? But it's not just in pronunciation of phonemes, but in stress as well. So mathematics in the Hanover German and Austrian German differ, Mathematik versus Mathematik. English is mathematics, and Indian English is mathematics, or mathematics. This is my favorite mountain. It comes from the state I was born in. And in German, it would be Himalaya and Darjeeling, I think. English is Himalayas and Darjeeling. In Bengali, it's Himalaya and Darjeeling. So when I first heard the word Darjeeling when I went to graduate school, I just couldn't believe it. I thought I was hearing something different, And the interesting thing is, when Bruce Hayes and I were working on the intonation of Bengali, he couldn't hear my pronunciation to put stress on the fact. So you actually don't hear it. If it's not in your language, you actually govern it according to what your language is. So Metrical stress in Germanic, if it is an inherited word, whether it's English, German, Dutch, Swedish, Norwegian, you get word initial stress. If it's a Germanic word, yeah, Hazel, Hazel. If you have, and similarly with angel or engel. The only exception are some verbs and adverbs which begin with unstressed syllables, like begin, become, bestow, behind. And even those, Swedish and Norwegian, happen to borrow them from the German again. I don't know why. Why on earth borrow verbs? Okay, they did. But once you borrow Romance words, things change, right? And we had the William the Conqueror coming in 1000 AD over here, but Romance has been continuously coming in, English earlier than the other Germanic languages. So these are inherited words, you know. And the kinds of feet you might get is either a single foot, which means light syllable, or a heavy light, says one heavy foot, or 2 feet, like 14, but main stress on the initial syllable. Romance words can be longer, but for English, the tendency in the early words particularly has been to go to the left edge. Yeah. So melon, parrot, pirate, lactose. You might get a heavy syllable, but it's rarely that you would put the stress over there. Yeah. That's not true for German, for example. So compare these words. These are English loans, not these all words we strictly were taken. Was from disyllabic words. English loans not existing in German, like pigeon and amber, but curfew and language had 2 stresses, 2 feet. German strictly final syllable, so pirat, agent, organ, costume, insect, impulse. But English was costume, insect, impulse, or pirate, agent, or matched in characters, alphabets, whatever. Isabella Fritz was very good. I wouldn't, but she did. Now, German penultimate, if you have disyllabic in English, choral, melon, method, but German trisyllabic penultimate stress, chorale, melone, metodo, legende. By the way, Dutch necessarily are not the same. They can differ. Neither will Norwegian and Swedish the same. It all depended when the word came in, at what time of the grammar. Here the task was lexical decision, hearing a fragment priming. Question is, if you are a fluent speaker of English, you've stayed in the country for 20 years, nobody would even probably recognize that you're not English, except for your name perhaps. Would your native grammar affect the processing, and to what extent? Would it matter whether they were 2 feet or 1 feet? My poor postdoc thought it wouldn't. She was quite depressed with all this different feet walking around the place. And whole word was related to the prime. Like, it's just a simple lexical decision, fragment priming. And in early tasks in fragment priming, if you change the stress, you can actually hear it. So MPI in Leipzig did a lot of work on that. And then unrelated, and et cetera, et cetera. So what we find is the following. So do the fragments activate real words? If yes, to what extent does the metrical structure matter? And predictions I had was that fluent, this is very, very new, so details are not there yet. Fluent speakers should have no trouble accessing English word. Why should they? They speak English beautifully. Nevertheless, their phonology may have some influence, and if so, how? Yeah. If they do not have competition in their own language, mind you, these are all Romance words, yeah, there should be more priming. If they do exist in their native language, then the variance in the foot structure could be reflected in their responses. Far-fetched. So here are the 3 conditions, and basically everything happily primed. But those words that do not exist in German primed more. So clearly, they were happier when there was no competition. Now, when you then look at the EEG, you can see that there is non-existing loans, differential waveform again. It is lower N400 priming effect for words that don't exist, but we get a positivity for those words that do exist. Yeah. That is to say, it seems later, around 600, they are thinking, oh, that was something different. But more interesting, I found, and this is again very new, so if you look back to these cases where they don't exist, but there's 1 foot or 2 feet, you find actually a difference. And the difference is here. If it is 2 feet, then it's okay with English listeners. That actually fits your language, and it doesn't affect so much. But if it is 1 foot, this is very rare in German because you had open syllable lengthening the first syllable. So this would be unusual kind of a foot structure here. And you get a much lower end foot. There's no competition at all for these words. So preliminary findings show that a syllable fragment successfully activates real words, but not equally. When there are no German counterparts, no competition, the amount of priming is greater. With respect to the control fragment, a lower N400 is realized. When there is competition, you have a later positive effect. So in sum, words and word structures vary. They are replete with asymmetries. What appears on the surface is not necessarily isomorphic. I have finished, so you can't threaten me anymore. It's not isomorphic to what is stored in the mental lexicon. I practice madly not to be, if you can, I can talk more about other things, but lexical representations are abstract, discrete, not fully specified, and exploit asymmetries. Asymmetry in representation is reflected in processing and language change. So the claim is that the native speaker's grammar constrains the way in which contrasts are maintained, accessed, and processing, which may reflect in reanalysis in the future. So the people who really did the work are here. Some of them are definitely here. And lots of grants who have been extremely kind in funding the research. Thank you.
Thank you, Aditi, for an extremely stimulating talk and perfect timing. So we have plenty of time for questions. I can maybe start if people are still formulating their questions. Can I ask kind of a chicken and egg question about the ultimate reason for this kind of asymmetry, representational asymmetry? So what's driving this asymmetry? Is it to do with the production system, the way the articulators work? Is it to do with the nature of the speech inputting comprehension? Is it to do with innate constraints?
Okay, I think I think it has something to do with acquisition, in the sense that you're faced with huge amounts of speech. Actually, you're not faced with huge amounts of speech. You get very little input in speech, but you have to extract something from it. Typologically, coronals always exist in a language. So in the articulatory organs, you have the tongue and the lips and the vocal cords. Let's say these are the basic ones. The tongue is not working for a baby till about way down the line. So you have your lips, and of course you have the vocal cords in terms of articulation. However, in terms of the number of sounds that the mouth can produce, and surely that is universal, because the mouth is universal, whatever your shape may be, the tongue does a lot more. So you have the coronality, the front of the tongue and the back of the tongue. You can get the dorsum and you can get the coronal, but the front of the tongue has more sounds. You can produce more differences acoustically, and I think that's important. Now, coronality, why did I want it to be unspecified? Why are they vulnerable? It's an odd thing because they are acoustically strong. So they are strong, and the way I have thought about it is that once you extract it, you can use that information to throw other things out. Thereby, it itself can be more underspecified. It's sort of backwards. That is to say, labial is very weak. So to use that to throw candidates out is going to be very difficult. Yeah. But to take dorsals are also fairly weak. They're fairly damp sounds. Coronals are jolly strong. So amongst them, if you compare amongst the coronals, then you have to use height or the part where the frequencies lie, lower or higher. Yeah. And so I don't know whether it's innate or not, but I think it's innate in the sense that the human brain and the human tongue union, they are what we have to work with. And if your hearing is working, the flexibility, the Jacobsonian principle of maybe the labial is more unique. That's simply because they only have the lips to make any sounds initially. The tongue is not working. But as soon as it works, in Paula Fickert and Klaasje Lever's very detailed Dutch phonology work they did, they discovered that the so-called consonant harmony, which you think is only appears in children. It's not really consonant harmony. It's a harmony. It takes the features of the vowel, and the vowel, consonants and vowel features match. So either they are labial or they are coronal. Yeah, that's all they can be. So it's a kers come much later. It's a b and u, or t and e. And so so vowels and consonants share features, and again, it's a question of higher frequency, lower frequency. It's as simple as that, I think.
So as I understand, this is about the nature of the articulators and the impact of that on perception.
Yeah,
okay.
And so the asymmetry is a simply way of saying, make use of what you have in the language. If it is equal, then it's much harder to distinguish things. And if it's asymmetric, you have half a chance of extracting information from. If you listen carefully to, I wish somebody would do this. This is not, stay there. This is not something I would do, but if I wish somebody would take data from misperceptions on the phone, where you cut off the 8,000 hertz, and there's lots of data nowadays. Data is the big thing, right? And if you analyze it, where do the misperceptions lie? I'm sure it's asymmetric. And no matter what the listener is, it's going to be asymmetric. So there's a challenge.
Thank you.
Hi, Claire Moore-Cantwell, UCLA. So I have a question about the Mandarin study. So my understanding of how sort of the basic premise of the experiments you've presented is that there's like this no mismatch situation, which is on the surface you have something specified, but in the lexicon it's not specified, so it's easier than if they mismatch, right? So for the spreading, I was trying to figure out if you think the spread feature is like attached to both segments in the lexicon. I got a little bit confused about what
they're
was
not attached.
mismatching there.
The assimilation happens on the surface. So the production is producing that, but the representation remains as it is.
Okay, so then I guess what's different about the spread case versus the unspread case, because both of them would be specified on the surface anyway and not specified in the lexicon, right?
Could you repeat that? I'm sorry, the rain,
Yeah.
my hearing is...
No worries. Okay, maybe I'm just not understanding, but so my understanding of how like spreading works, it's a phonological process. It doesn't have to be represented in the lexicon. So both the sort of unspread case and the spread case would be fully specified on the surface for all their features and like not specified in the lexicon. So that seems like they should both be no mismatch.
No, because the sir and the sh themselves differ in the representation. But the height of the vowels don't. I mean, one is high, one is low, and one is coronal, one is dorsal. So it is a question of both directions. The surface will extract all features, but if you have assimilated something, you're going to extract that feature. So for example, similarly with handbag, if you're hearing handbag, or the Chaucer scribes who heard impatient, heard a name and wrote a name. It's as simple as that. But if they had heard, I mean, it's also interesting in language what sort of things you don't have. For example, prefixes ending with labial are almost unheard of, except in German they have an up, but why? Probably because there is a reason for that usually, why things haven't developed. So it's the surface has the features. The representation doesn't change.
Thank you.
Yeah.
Hi, Sol Lago, Goethe University.
Could you take your mask off? I'm hard of hearing plus everything else, yes.
Is it better?
Yeah.
Yeah. I really liked the last experiment. I thought it was really cool. My question is, and I'm not sure I got it correctly, so these are single words, right?
This is
The Romance borrowing data. It's from single words?
the fragment, they hear fragments and they see the single word.
Yeah.
Yeah.
And my question is, would you expect the same kind of influence if those words were like in sentence contexts, for example?
It depends on the phrasal context. So for example, if your phrasal context has encliticization, then you would have a different property. Yeah. So for example, if this was Norwegian or something, and you had a clitic context, then your tone won't change. But your syllabification will change here. But your metrical stress your foot structure remains the same. So if you have, for example, if you have a context where you get a rhythm rule context, so 13 is 13 lexically, but if you have 13 men, then you would get 13 men, right? But what changes is not that the feet have gone, it's just that the main stress has shifted. There's a stress, if there is stress clash, you would, depending how you're going to deduce the data, there should be, but you wouldn't suddenly add a stress. Stress doesn't assimilate, for example. I've never heard of such a thing, no. I hope not. That would be dreadful.
Thank you.
There's still time for more questions if people would like to ask.
I think people are tired.
Yeah. Well, I'm going to make them a little bit tighter and ask one more question, if you don't mind. You had this study early on where you talked about priming of sonnet by sonnet, I think.
Yeah.
And you mentioned that there's some kind of checking process that might take place, so that people know that sonnet isn't
Yes, exactly.
sonnet.
It's the immediate reaction that you get, the acceptability. But after that, you know it's not a word, right?
So my question is, how do you know? What are you using to interrogate that?
I haven't done anything with it because I got tired of looking at the same things, but somebody ought to do that if in another language. Because initially, the word acceptance rate, so we very carefully looked at the reaction times as well, and in the reaction times, you are slower because that's precisely where your acceptance is, or what is it? But you definitely see a positivity effect, which means that I'm rethinking it. And similarly in the stress, where the words do exist, and you could, if you have 2 feet, you could stress the second feet, and then you were wondering, what did I hear again? I think you have to rethink. Now, I am no neuropsychologist, so I think somebody better than me should be able to try to figure out precisely what is happening there. But obviously, you know something, but what you know is probably what your grammar has, yes. But what really surprised me with the pigeon and the case is that, I mean, I was hoping I would get it. I didn't think I would, that the structure like pigeon is so un-German, that is to say a light syllable, is, you get it in Germanic words, but as soon as you have Romance words, you don't get that because they are lengthened, or you have final stress. So it really had an effect. So it's just the knowledge of what the words ought to be like, yeah. Subconsciously somewhere.
Thank you. Okay, I think that may be it. So if so, then we should just thank Aditi once again, but also all of the speakers in this morning's session. Thank you very much.